In this section, we're going to study prime numbers. This problem is more difficult than the other case studies that we've done so far. It is a mathematical problem, and it takes a certain amount of mathematical reasoning to get a good approach to solving it. Particularly with mathematical problems, it's important to understand the problem. Do it before any coding is done. The hardest discipline I'm aware of for a programmer is to think it out, write out potential solutions on paper, think it through in the mind, check it out, and then once you're convinced you know how to solve the problem, write code. When you do write that code, it'll be rather easy, and you may feel like you haven't really done a lot of work. With more difficult problems, it's often preferable to break it into smaller chunks so that you can solve each chunk independently of the others, ensuring that you think through, design, and implement a good solution for that chunk. Putting them together also takes skill to make them work, but once done, you have usually a very good solution. A number is prime if and only if its divisors are the number 1 and itself. For example, the number 7. 1 divides into 7 and 7 divides into 7, but no other integer divides into 7. This problem of discovering primes is one of the key problems computer scientists and mathematicians work on. The author shows one solution. The number to be tested for prime is divided repeatedly by larger and larger divisors. We start with 2 and we go upward one at a time, and we determine, does this number divide the target number? If it does divide it, then obviously it is not prime. We start with the number 2 and we go up to a maximum. The author offers n over 2 as the maximum number to check in the loop. But there's in fact a better number, that is the floor of the square root of n. That slight difference for small numbers would be practically unnoticeable. But for large numbers, this could be an order of millions or billions of iterations. Obviously, this approach is not the ideal one anyhow, but this is a case where clear thinking in mathematical terms really helps produce code that is optimal. Always consider optimizing loops when there is a large number of iterations, especially nested loops.